Hey guys, welcome. So today I'm going to work on a Nixie clock. So someone of our subscribers asked us to have a look at, can we make our own Nixie clock? I actually have no idea what that is. So we're going to see if we can make a PCB. But the idea is for you guys to join me. If you have any PCB questions, any help needed, feel free to join me on stream. And I will answer your questions if I can. Cool. Let me just get all stuff ready. So we want to make something like this. So we'll see. Ah, come on, lost the music. Cool. So let's see if we can make this today. I actually have no idea how to do it, but we're still going to find out. We're working on KeyCAD today. Cool, so let's get started. Like I said, I actually don't know what I'm going to do. Hey JS, how's it going? So someone in our Discord asked me to have a look. Can I make them a Nixie tube clock? I've actually never seen any of these before, so I just want to see what components are in it, things like that. Doesn't seem too complicated. We just need to buy those. How are you doing today? There we go. Okay, so it's that. 12 volts to 180C converter. What? That sounds a bit crazy. I'm good. Good. 18 volts to 180. Oh, dude. Is that the voltage that these bad boys take? Wow. It should be easy. Shouldn't be too difficult. So it seems like the 180 volts is inside there. Let's just see how they look. Hmm. 180, 170. That is high voltage. Can I get it from where I stay? Okay. Seems we can do it. So doesn't seem too difficult. What is this? Yeah, you asked me to. It seems like we can do it. I've never seen it before. PCB to but are you ready to play with some high voltage? Because I see it takes 180 volts. You mean this? Way ahead of you. Yeah, but is it just the clocks itself or is it separate? Let me open Altium. So guys, I will carry on with my projects, but if you guys have any questions, please just ask. I will stop and help. So I've got a question here from JS. I want to know, when using ESP in designs, do you make schematic or download from list and use Altium? What do you mean? Do I make schematic? Do you mean the footprint or the circuit? So the footprint. I normally take it from the database, but the schematic I make. I'll just open all the programs so it's easier to jump across the different software. Jazz expensive clock, 300 euros. What makes it so special? It looks very pretty. The footprint I'll show you now. So we were busy with so many different multiple charger. So last time we were busy making a charger for multiple LiPo batteries, because I'm busy with the drone, guys. It's going quite well. I think I'm almost done. I'll make a video about that. But I normally, if you go here, place part, PP for place part, and then I'll go ESP32, and I'll go manufacturer part search. So Altium has this big database where you can just use stuff, and I will use this. So the symbol here shows that the component, they've got a footprint. You should be able to see it. It's at the bottom here somewhere. there, component there. And then I can drag this across. I first click on it, yeah, that pops up. So I would do this. Only if it's not here, I will make my own design. So making your own footprint is fine. But the nice thing about this is if you click on it, it tells you the price. It gives you a data sheet, all that fun stuff. Does that answer your question, JS? No, I've not. So you can see I've got both open. So I'm going to do the clock and KiCad. But so this stream is not just me doing a project. I try to get people on as well. So sometimes people will join me on stream and I'll help you one-on-one with your design. So it's not really my project stream. I do it on the side waiting for people. But if someone has questions about KiCad or Altium, I'll just pop between the two and answer them. That's the idea of these streams. So I keep myself busy until someone pops with questions. But I'm not paying 100 euros for a tube. I just want to see the pinout, how they actually work. So it's quite simple. You just apply voltage and the number will appear. But I want one I can get in Netherlands. Dixie clock. Yeah, Krish. So Kamikaze asked me if I can just look at this project because he's quite interested in it, and I'm in between projects at the moment. So I'm looking how we can make this as community again. So that's the idea. Yeah. So it just seems that. Let's understand it. I don't know. Like I mentioned, I've never worked with this before. So let's just learn together. So you guys know the difference in anode and cathode, it's just positive and negative. So the way I remember it is panic. So positive is anode and cathode is negative. Because I always forget, so I just say panic, positive anode, negative cathode. So yeah. So there's a comma. So it's common anode, and then you just change the negative to switch on a number. Hey Pranav, how's it going? Haven't heard about you in ages. Yes. So what I'm assuming is going to happen is we are just going to have some power MOSFETs, transistors, and just switch between it. So we'll have a Arduino or ESP just controlling the signals. That's high voltage, so that's my biggest worry. So of course in Google there's always tutorials, and I'm just trying to get a feeling for it. Let's look at a circuit. Let's cheat and say Arduino. For absolute beginners. Hey, that's me. I'm just going to browse through it. Your parts. So RTC is real-time clock, if you guys don't know. It's quite high voltage. Okay, so we just need to choose a nice IC to drive this. So honestly, you guys, if I want to do a project, I normally just look what's been done before and try to understand it. I'm not going to reinvent the wheel, but we can make it nice and personal. If you guys don't understand some terms, maybe I can help you. So they're using 12 volts, 25. So this IC just takes your, I think, your mains and then just creates it to 12 volts. Seems small. Very important. I like looking at pictures. I'm a very lazy reader. Seems we'll be using a shift register. Yeah, so we're just going to change that, it seems. So it seems the only thing we're going to do is make our IC distinguish between the different. And they use a shift register because I assume there's not enough pins on the Arduino output. And it's, yeah, you save a lot of pins using it. Yeah, it's a circuit. We're actually using the shift register for another project at the moment. This is all we need, guys. We can do this. So how many tubes should we use? I'm going to have to make the footprint for this tube, I think. I don't think it's going to be too bad. I think we'll start simple. Just get it working. I just want to check the footprint because we are going to have to make a footprint for the tube. I don't think, so let's first find the one we're going to use because we have to be accurate in this. Not pin. Does anyone know where to get this? What link? Oh, this one. I think that's exactly where I was. Oh, this with Arduino. Just thinking how I can copy it. Oh, I need to go on because I'm using a software The software is not allowing me to copy it nicely because I'm streaming in different platforms. I wonder if I can copy it. Copy? No, I can just block you. But I can just search for it. This one. Yeah, I had this open. AliExpress. I just want to see the tubes because we're going to have to make footprints. Or do they come with wires? What do you do if you need to place holes for providing power and signals but don't want to place connectors? I normally place a jumper. Depends if you want through hole or in KiCad or Altium. So I can go. So in Altium, in KiCad, I normally just place a. Just down at the libraries. I'm thinking now. So you can place. How can I say this? Normal connectors, like the 2.5 for pitch connectors, just normal generic ones, and just not populate them and solder. And if you want to solder SMD, you can just place a pad on the PCB. So if I go here, I can place a pad. And I can change the size of it. So I can make it, here's the V bus. I can make it something else, VBAT1. You can change the size of it, I think, somewhere. So there I can make it like that. That's one way you can do it. You can solder onto that. Just thing you have to do is nothing really, because you just have to make sure it's connected here, but here you already have it. So it's already, you already made a pad to connect a certain way. So if I want to solder my battery, I can do this. I can just copy it, place another one there, and make this ground. I've got two places I can solder wires on to, place two wires on to solder a battery or something. Does that help? And there's templates here, so you can make it like different stuff. You can physically do it yourself as well, the shape. You can get any shape you like. Hope that helps. Through a hole, you would just make a pad, make it round. That's a hole around. Through holes, if you go back to pad, then here you can see your size. So let's say 5 by 5. And then you can see your hole size. I want it, this is massive, and I make it 3. And then you've got a through hole where you can solder. So you can just push P, place, pad, PP. And then with this pad, you can do different stuff on the right-hand side here, choosing the shape. These templates. Does that help, JS? I can't copy the link, so I'm going to Google it. Title P. Ah, but they've already got the PCB. You're taking away the fun of it. So what do you want me to do? We can just take this. It's right here. Must I open it or? Everything's here. What a nice guy. There's some heroes out there. Perspective. We might as well just take this and then add our own twist to it. I don't know what this is. It's loading. But what we can do different is, so he used ESP as is. He didn't use his own ESP IC. But then, Kamikaze, then what would you like? Because I know you would love this project. Shape-wise, how many digits? JS, did I answer your question about the through-hole and pads? Not too sure what I did now. Hey, there's a circuit. So let's just look. Yeah, we can. But what I would change is, so what he did was, this is a ESP module on its own. It's a dev kit. So I would probably rather put my own IC there. That's one thing. But it's nice that I can use the footprint. And they use the shift register like everyone else. Coil. LEDs power. Just trying to go through, make sense of everything. Yes, that is the plan. But I just need to see what he's actually doing with all the stuff. I think this is for one, but it doesn't run at 3 volts, does it? Doesn't it run at 12 volts? Nine volts in, strange voltage. Nine volts. Nine volts to 5 volts, okay. But the ESP needs where's the 3v3 coming from? Where's the 3v3 conversion? Or does the... Yeah, okay. Okay, so he puts 5 volts into the board, and the board makes it 3v3. Great. That is good, JS. Yes, it does. So we put 5 volts in, and then this has a voltage regulator on it and just outputs 3 volts. Open, damn it, open. Hey, I see Chris joined me. Hey, how's it going?
Hi, nice. I managed to hunt about half an hour
Sorry, you've
today.
often...
Yeah, so I will continue the PCB with you tomorrow. So we will start off today. Then,
Oh, what PCB you want to do? You want to do the drone, right?
drone one, the my version.
Yeah, but your version's the built-in bolt components, right? The board components, so the physical.
Yeah, I mean, in my version, I was thinking I already have two ESP32s, the one which you gave and one
Yeah,
which I had ordered earlier.
yeah.
So what I'm thinking is to take that one and then put it on it and then control the rest of the drone using other parts on the same PCB. So maybe some
From
parts can be there under the ESP32 with that gap in between. So like we
yeah,
can hunt for space.
you must just look at the space that you need, eh? The size, because
So I have so I have a diagram for that. It is 8 into 2.5 centimeters. So it's a
okay.
rectangle. So
So
that's the available space.
we can have a look, because what time tomorrow will suit you?
Mm, 11 for you.
In the morning.
Hmm.
Okay, sounds good. Yeah, because I'm probably going to tonight finish or run off the code for the drone, so it's going quite
Hmm.
well. So
Okay. So
last night,
you must be doing it on Arduino IDE.
sorry,
You must be doing that on Arduino IDE, right?
yeah,
That's great.
not Arduino, yeah, it's the Arduino bootloader, but the IDE you can use anyone.
Yeah.
But yes, I found help on the internet. So it
Hmm.
seems like there's gonna be a web page that you can control the drone. So you just have your app and you can fly it. I got
No,
this one.
I was thinking there is this Blink app. Through
I've
that
got
you can.
I've got the Blink app. I was starting with already.
Okay, so you are controlling through Blink, right?
Not now, because that's going to be
Okay.
extra. I first wanted to fly, so I
Huh.
found a generic one that I can use, and then I can play with the Blink
Hmm.
app. So I've got the Blink app. I can read the position. I can control the motor speed, so it's fine. But now I have to start playing with the PID loop, things like that. So that's where the
Okay.
difficult parts comes in, is the control
Hmm.
system.
Right. Right.
Yeah,
Right. Right.
but it's making progress. So
Hmm.
I'll release another video soon, and then hopefully everyone can have a drone
Yeah.
that
There
doesn't...
is one good thing for me that ESP32 can also be programmed with Python. So I know Python better than C++ or C hash.
Yeah,
So,
that's not gonna help you with the drone, eh? Then you have to program it yourself.
maybe let's see how it goes.
Yeah. So I will give the code free, of course. So I will give the
Huh.
whole ESP
That's
code.
open source from you.
Yeah, so I'll just give it. Python, I
Hmm.
don't know. It's micro Python, right, or something like that.
Yeah, it's Python.
Yeah,
It's actually Python, but I don't know why they call it MicroPython. It
because it's
must be
for
some other.
microcontroller. No, it's probably for microcontroller, so they just put micro in front of it. But
Could
yes.
be. I mean, yeah, because
But
uh
is there a reason why you don't want to do C?
no, not exactly. I mean, see, uh, in our school curriculum, we were first taught Java from like grade 9 to grade 10. Then I switched boards. So now I am learning Python in grade 11 and grade 12.
Okay. Yeah, okay. Java is not going to be programming microcontrollers. That's more
No,
software
Java is
based.
not used. Java is not
Yes.
used here, but Python is useful.
Yeah, but if you want to go like work for a company one day, you will not
Hmm.
program a microcontroller with Python.
Yeah.
You will do
I,
you will
so
do.
I can learn C during college.
Yeah, you can, of course. I'm just saying it's nice to play with C. Python is good for scripting, so we do use Python in the real industry, but that's to run
Hmm.
tasks and testing and stuff. But to program hardware, I've not seen anyone do Python before in
Okay.
the industry, no, not hobby at home.
Exactly.
But yeah, what class do you have now at 4 o'clock? Or
No, tomorrow I don't have any classes.
okay,
So I will be free from uh, 3 or 3:30 IST, so that calculates to 10:30 and 11. So I will be free till like 5 or 6.
okay,
So so I till 1:30 for of your time. 11 to
okay.
1:30, and then maybe you can continue the stream or then come back later.
I doubt I'll stream that long, but yeah, we'll see. I just take it day by day and see who I can help and what happens.
Yeah. So should I share my screen and then you can help me accordingly?
Well, now or tomorrow?
No, we can start today.
Okay, if you
I
want to.
mean,
Yeah.
yeah, just an overview. Uh, mm, yeah, is it visible?
Yes.
So this is the dark mode for KiCad.
Yes,
I don't
yes.
know how. Yeah. So I think I need to go to the schematic first.
Yes.
So what is this? Copy default globals. Okay, this is recommended. Let's see. Yeah. So this is the, yeah. So I can copy the schematic from, no, wait, I have to, uh, no, you start. I mean, I don't have any idea.
No, no, but nothing's open. So I don't know. Did you open a schematic?
I opened, can't you see?
No, I think you're
Uh,
sharing the application and not the screen.
oh, oh, 1 second, 1 second. Hmm. I will share the whole screen thing,
Yes.
entire screen. I think now it is visible. Yeah.
Yes. Um, okay, so you first need your ESP32, right?
Hmm.
Do you know how to place a component?
No, I'm learning this for the first
You
time.
should watch my videos. Push play.
See, I have watched it, but I wasn't able to like spare the time out and then apply it really. I have watched it with the recommendations and such, but I wasn't able to I wasn't able to follow it as a tutorial. That's the
Oh,
thing.
no, no, then it's bad videos. I'll have to speak to Kerry then. No, but you must tell me that because then the videos are horrible.
No. I'm not saying that, but
I'm saying that if you can't follow the tutorial, then it's not worth it, right?
no. I was watching them. I was watching them as normal videos, but not as tutorials.
You must pause and stop and stuff.
Uh,
So you must push A, A for
A.
placing, A for, I think, but you using Linux, right?
Ha.
Yeah, it's the same.
Yeah. Ha.
Type in ESP32 there. I wonder if your library has it.
This one.
Yeah, so you can use the room 32 or 32B.
Yeah. I have room 32. Yeah,
Yes.
correct. Okay. So, oh wait, I can place this here, right?
Yeah, but you need space on the left-hand side, eh? Because you're going to have wires and stuff.
So I will place it here. Yeah.
Zoom in a bit.
Huh.
So there you can see
Oh.
all.
Just give me like 2 minutes. I will get my mouse. I am using my touchpad.
Okay. So how's everyone doing? Yeah, guys, if you, it depends on what you want to do. If you just want to program as a hobby, I've never used Python, so I can't say. I prefer C. And Arduino is also not real C, pure C, but it's to get something working.
Yeah, I'm back.
Welcome. So you know about the ESP board. You got the I/O pins on the right hand side.
I know a bit. Wait, how do you control the screen? I mean,
Yeah.
uh,
This is your first time opening KiCad.
no, I have opened KiCad, but I have not imported stuff like this.
Okay, but that the chip we have there is the IC. We don't want the IC. We want the
Ah,
dev board. So delete
ah,
that because you're gonna
okay.
put your dev board on the PCB, right?
Right, right.
So
One second.
search for ESP. No, delete that.
I
Push A
have pressed
again.
undo. Yeah. Yeah.
ESP. Just type in ESP32. I just see if you have it. Otherwise, we need to find it somewhere.
Yes.
32. Is that dev board somewhere? No.
Uh, no,
And
actually, what we want to do is we have to create spaces for the I/O pins, and then create the PCB, rest of the PCB around it.
yeah, but you need to plug in your ESP32, right?
Yeah.
Yeah. So
So,
it's easier then to have a footprint that has that footprint, and you can see what the pins are for the ESP.
right, right. So we can import ESP32, then this thing, and then
Not that one
do
though. That's the IC. So that's the loose IC. So,
that
so
you were making. Yeah,
yeah.
yeah.
So this one still needs the transistors, still needs the capacitors, resistors, all that stuff.
Yeah.
Um,
So, is there any thing that is available online?
yeah, there should be. I'm going to try look now quickly.
Hmm.
I'm not. I'm sure Linux will be the same, but if you have ESP32 room dev git KiCad library. Let's see if we can find something. I'll just search a bit there. I'll look again myself. Otherwise, this Nixie one has it.
Which site?
No, the Nixie clock that I downloaded has the footprint, but it's part of the schematic. It's not part of the library. So just go
Oh,
ESP dev kit footprint, KiCad footprint.
okay.
Can I? I can. Is it
Hmm.
something you want to learn or?
Now, are you asking something?
No. It's I see JS asked, can we create a custom schematic and footprint? Anything's possible, but if it's on internet, then it might be quicker. Let's create it. Let's create it.
So this. Oh, yeah. So I was looking for this, right?
Yes.
Yeah. So I have to download this, right?
You're gonna have to create the profile and all that stuff, eh? So you have to go KiCad
I.
version 4 and
Uh,
later.
yeah.
Yeah. Yeah, but they won't know everything.
Acha, I will
But let's.
turn my screen share off for a moment then.
Do you have a we
The,
can make the component, eh? And then people can learn. You can learn.
so you are telling to make the whole component. Uh, I will cheat this time.
You're gonna have to learn it sooner or later. No, but that's fine. You download that, and then we can try and import it.
Okay. I have to create a username. I don't have a company. Do I have to download the symbol and footprint both, or just the footprint?
Both, because you need the symbol in your schematic.
Okay.
Yes. Just for JS, we made a YouTube video about creating it. I don't know if you've seen it. Sorry, Kish, I'm answering comments.
Oh, okay. I understand.
So,
I got you.
get a link. But you want it for Altium, eh? JS, do you want it for Altium or KiCad? That's important. Because I haven't made a tutorial on Altium yet. That I need to do. Okay. Yeah, okay. So I will make a footprint after we're done with this. I will make a footprint in Altium for you. Guys, must we make the Nixie clock in KiCad or Altium or both?
Yeah, my Wi-Fi got
Yeah, I
disconnected.
saw you went away and came back again.
Right.
Are you winning there? I think I could have drawn it faster than you downloaded it.
Yeah, I have to prices. Then I thought, do I have to buy this?
Yeah. Krish,
Yeah.
just let's make it quickly. I'll show,
My
I'll show you on
I'm
my
having
screen how to make.
issues.
I'll show you on my screen how to make it, and then I'll share the library with you.
No.
Do you know which dev board you have? Because there's two variants. There's a battery charger one and the one with the two buttons. He's not with us anymore. It's so strange without music. It's like eerie. Okay, let's refocus. JS, you would like Altium component, right? What component would you like me, to make? Let's be practical about it, and then because then if I make it, you can use it for a project you're busy with. ESP12E. Never heard of it. So it's this. Let's just get the data sheet. What made you choose this chip? So when you create a component, you need to just see the pinouts, of course. So I normally just go some information, pinouts, footprint. So your footprint's normally at the end. Why is the footprint not here? You can use this, I guess, because it tells you the thickness, the pitch. Normally it's a better picture than this. Chinese. I need to know what's pin 1, pin 2. I just need that. Okay, I understand. Now I'll make the IC for you. There's no problem. The footprint. I just want a proper data sheet. They all look the same. I need the pinout. Okay, so I can work with this. Split my screen. Because it's important for the schematic, for your schematic to have pinouts, and then for your PCB to have the footprint. So let's just, so I've got the pins here, 1, 2, 3, 4. So in Altium, you can go File, New, Library, Schematic Library. So the schematic library is like a full-on database of all your schematics, of your symbols. So you only have to make one library, and you can make all your schematics in there one by one. So one component's in here, but you can see I can add many components. So I'm going to make a plumbpot library. I already have a library actually that I made. It's on my laptop. So I'll merge these two because I put it on GitHub so people can just use my components. So we're going to make this ESP12E. Designator, we normally make U for all ICs are normally U. And then you can say ESP32 or Wi-Fi, Bluetooth. See, there's no footprint yet, but we'll get there. So what I do is I just place, you can see as IECC symbols, we'll get to that. I just place a rectangle. So when creating a component, no worries, Krish, I'll see you tomorrow. So when you create a component, just put them, my music is a bit loud. Don't know about your guys' music. Let me know if I'm supposed to softer. You get your how it's going to look. So it's pretty basic, one of the square, and then you place a pin. So the pin is going to be how I connect it. You see the jumps are pretty big. That is because my grid is big, so I just changed the grid. Guys, this concept can be carried over to KiCad. I'm sure it can be carried over to Eagle. So the concept of component design stays the same. You have how it looks, you have the pins, and you have to merge between your PCB and your schematic. So there you can see. This pin is a bit short. We can make the pin length a bit more here. I'm going to just snap this to grid. It's not lining up. Change is not lining up. There we go. Strange. Yeah, you can choose a let's see too. So, oh, come on. No. So this is the connection where the wires can be connected. In here, you've got your designator and name. So the designator is important because you're going to tell your footprint you're going to make that in my footprint, this is pin 1. So the designator is very important. And then the name you can call anything. So we saw here, pin 1 is RST. So we'll do the same. We'll call it RST. I'll just let me know if I'm going too fast, too slow. You can see it's going to be a bit small. I just like to make it in the corner and make it some nice. Oh, you must click on that. Don't know why it's not lining up properly. It's ugly. Anyway. So let's put pin 1 on top left. You can do this anyway because you already told your people pin 1 is here. So the name can be anything, but this designator is very important. So I'm just going to put this one side so I can have the cookies. So pin 1 is RST, so we've got pin 2. So I can just take this and just copy it. Hey Ramesh, how are you doing? I'm good, thanks. Just showing JS quickly how to make a footprint in Altium. How many do we have here? We've got 22, so 11 on each side. Hey, Adiat. 6, 7, 8. So we're going to have 11 and 11. 9, 10, 11. Copy this so it keeps the same rotation. 1, 2, 3, 4, 5, 6. How are you guys doing? I can just neaten up a bit. So this is just your own preference. You can actually do whatever you want. The designator is important and the name for you so you know what you're connecting. But anyway, so now we can go, pin 1 is RST, pin 2 is ADCT out. I'm not too sure what that is, but so we take pin 2 is your designator, and we say ADC. It looks like there's only one analog to digital converter. And then we've got 3. This PCB is about not anything. I'm just showing JS how to create a component. So he's busy with the gesture control. I don't know if JS, you want to tell us more about it? gesture control PCB, and he is busy using this IC or this board, and he wants to make his own PCB. So I'm just showing him how to make the footprint for this so he can use it in his project. But on the other side, in between, we are busy making a Dixie clock. So we're going to make one of these for the community. So we'll share it, of course. Yeah, so I don't know what to call him. Kamikaze, Water. He's all different names and all different social. He wants to make one of these. So we thought, okay, let's see what we can do. How are we going to make this? So yeah, we're not going to pay that. We'll pay for the components. Anyway. So like I was saying, pin 3 is enable. After the schematic, I will make the PCB footprint. Pin 4 is IO16. I normally use the IOs because then you can just, in your program, do it. So you can see I'm just taking the numbers here on the right hand side and putting it over. No rocket science. Just tell me as soon as I do something that you don't know, unsure about, please. Just stop me. You can also say if it's input, output, all that stuff. But let's keep it simple. Mostly in MISO is communication protocol, SPI. IO9, 11. Schematics, this is normally the boring part. The making of the footprint is quite the nice part. So let's go one, make this 12. INT is normally like a interrupt, so external pin interrupt. It does when you, so in Altium, I always think before I talk, because sometimes I just talk rubbish. In Altium, you can push CC, and then it compiles it, and then you see some errors here. So if you configure your pins correctly, it will tell you that you've got an input connected to input, or output connected to output. So it can help if you do it properly. There's no downside of it, but technically it won't hurt, if you know what I'm trying to say. So these should make IOs, and that also changes. So let's do it. And also, yeah, I'll get there later, but Altium also, you can put the spice models. I don't know if you guys know about that, but it's just like Alti-Spice. Your component has certain characteristics, and you can put that in Altium as well, and you can simulate your designs. So maybe we'll get there, that's advanced. Yes, it will output that. So it will warn you that I've got an input connected to input, and you don't really want that. Yeah, or I've got two suppliers that's shorted. But the biggest design rule checks are on the PCB side. But let's do it. Let's do it. So this is power. Don't have to have communication. That's output, Mosi and Miso. It also makes these nice symbols. Reset to input. Analog digital converter, that's probably input. Enables input. It's just when you choose it on the right hand side here, when I make an IO, it becomes 2 pins. So the software does it automatically. Altium is really, I'm not sure what this was, 14. 14 is your clock. Sure, this clock is, I think it's an input clock. Ground. Reset 16, I'm losing focus here, IO 15. Can I post my project? Of course. Do it on we got the community channel. So on the left hand side, where's it now? Maker stuff. There's community projects. So just put your community project there and we can chat about it. I'm very eager to see what it is. So what exactly do you do with the gesture control? I think you've told me before. I'm sorry if I forgot. I'll blame Corona. No, I'm joking. To IO1. Why not show? Cool, man. So you have a basic one working. That's very interesting. Lost my page now. Played FIFA. Is a gesture with your hand. So like, shoot the ball. Shoot. Go away. Please post that video. I'll be interested to see. Guys, if you're not part of Discord, I think hopefully the link is below. Just remember to thumbs up in the rules, otherwise you can't chat. It's just to say that you agree to be nice, respectful, just have fun. Cool, so we've got all our 22. Let's place a text. Yeah, I'm sure you learned a lot with that. What sensors did you use for the gesture, for the control? Like the ones that measure your muscle movement, or? Cool. I think that's good. So we can save this. I'm going to call it just Blancpot. So like I said, that's my big library. And in my library, I can have many components. Now we have to make the PCB. We say File, New, Library, PCB library. So here's where the magic happens. So same as the schematic library, we also have a big library that will contain a lot of our footprints. And we, like you can add. So we just put this, make the name ESP12E. JS asked me to do this. Okay. Then you can put the height as well. Yeah, that's more important. Yeah, it's fine. Just some options here. You can also put a thing that's not in the BOM. Yeah, graphical, all that stuff. This is a standard part. The height is important if you set up your rules in such a way that you want a board on top of another board. So you need to know your clearances. So you put the height. So Altium will actually check the height of the components. So for collisions. Oh, wow. What IMU did you use? The 6050. I've got that on my drone. That seems pretty stable. It's pretty good. So here we can start. This is where it becomes a bit more, not complex, but oh, here's the pins. Let's see if they've got a footprint. Schematic. So I'll use this as a reference. Just trying to see how I can make it So this 16 by 23.90, yeah, that's crazy, is the mechanical. So I can just place line. I don't want a mil, so I push Q and it makes it millimeters. I'm going to make it 24, man. I'm not going to, it's millimeters. And then I've got 16. And just copy this. In Altium, you always copy respect to a reference. So what I mean by that is if I copy here, press copy, I have to click somewhere that it uses as a reference. So I click normally at the point. So when I paste, it will go like this. If I go here, copy, and I point up here, then up here is my new reference. And when I paste, you can see the difference. So copy, choose a point, paste. I don't see the length of the pad. There you can see the height, 3 millimeters. Oh, wow. That sounds interesting, man. That's something I've not played with. So let's see what we can do here. So we got 1, 2, 3, 4, 5, 6, 7, 8, 6. So we can place a pad. So as I explained about soldering, it's the same concept. So I've got a pad. I wanted this funny shape. Rectangle. Don't want hole size. I wanted S&D. No. It froze. It froze. No, it didn't. Back again. So you can see at the bottom, does it tell us? VCC is bin 8. So the left bottom is 8. So this is where the important part comes designator, so 8. So when I change designator 8 here, it will tell my PCB later. I'll show you how to link it. It will tell it, okay, cool. It's the same as this bin 8 over here, which is my VCC. I think it's slow. Yeah, bin 8. But we only want a top layer because you can see only want a top. So we only want one layer. So this, there we go. we want the thickness to be 1. So we make it a bit bigger because this is the physical pads. So we make it a bit bigger to solder on. That's the position, I think. Here we go. So make 1.2, 1.1, 1.1, 10% tolerance. The length, can we calculate the length somehow? They're not giving it to us. Normally a good data sheet will give you the exact footprint. So I'm looking for that length. We can probably calculate it somehow. Or missing it. Do you guys see it? Let's just move it. We know it must be 1.48 from the bottom. So this is our 0 point. So y must be 1.48. Now it will be perfect. We'll lock it because you want to move around. I just have to find out the thickness, but this is the idea. And then you can see it is. Is 12F and 12E the same? But you must be able to get it from a data sheet, right? So if I just take a 12F or 12E, it's the same. It's just a different chip. Yeah, but I want it from like a source from them themselves. Like I can go here, PCB libraries. No, this looks dodgy. Yeah, so I can get it from different places, but like, where did they get it from? Strange. Very strange. What's the difference in the ESP32 and ESP12? I've never used the 12, to be honest with you. Can't believe they didn't give you a proper footprint. But anyway, the idea was just to show you how to make a footprint. Let's do this. This will help. ESP32 12E. Oh. Okay, and then the ESP32 is Bluetooth as well. So what I'm going to do is I'm going to put the step file on here, then I can see if the lines up. So I'll just go, damn it. Place body, I think, place 3D body. Oh, yes, definitely. If you build something on the breadboard, you know that's working. Don't try to be a hero and introduce new unknowns. You've got the concept. I was just wondering the difference. You can see it looks a bit strange because it's not rotated. Always the last one. So you can actually see my drawing was perfect. It doesn't have to. Should be fine. Yes, I'm happy with that. Now it's just want to see what the pitch is. No, it's not this. I'm running out of which tabs I used. So the pitch is 2 millimeters. So it just means the gaps between it. It's magic. I go to a website called GrabCAD, best website ever, and then someone drew it for us, and I just downloaded it. And download the step file, and then I can just push place 3D body, and then I can import it. So I always go to this website. It just makes your PCB design look so cool. So you can use it in KiCad or Altium. Glad I can teach you something. You happy with that? So GrabCAD. I'll put it in the comments. It's really a cool website for step files for PCB design. So this is where the reference comes in. Okay, so my 2 millimeters. So I can copy this, right? Copy. Let's just say I copy it there. I want this X to be the same. And then the Y must be 2 millimeters more. So this is 1.48. So this should be 3.48. But I don't want to keep doing that. Designate is important, guys. 7. Lock it. Lock. So what I can do now is I push copy. And I copy it with the center point there as a reference. Why are you not snapping? All layers. So it snaps on certain layers. So you can choose current layer. So I copy. Yeah. So every time I paste, I will paste 2 millimeters from each other. Because I used the next one as a reference. Let me know if you guys understand that. I'll try to explain it better. So I copy it. I choose a reference that is 2 millimeters away. So that's my new paste reference. 8, 7, 6, 5, 4, 3, 2, 1. There we go. Now we do the same. And now you can see it actually starts looking like something. We'll do the silk and stuff as well. We've got the bottom. So the bottom we do the same. We make this x is what? No, it's not. It's 3. 1, 0. Yes. KiCad doesn't have the reference. KiCad doesn't have the copy reference thing. So with KiCad, you have to use a thing called move exactly or position relative to. So if you use this, I can select the item and I choose that, and I want to be 5 millimeters away. So that's the way you do it in KiCad, if that's your question. KiCad doesn't. So in KiCad, if you copy it. Oh no, I'm lying. There's also a reference point. I lied to you. You can't trust me. So yes, it's the same way. You can choose a reference point and then I paste. So yes, it's exactly the same. Can't trust me, man. I lied to you guys. No. Well, it's nice with the picture. You can actually see how it will look. So we can see. Yeah, that's fine. A bit too long, but it doesn't matter. I assume this is 9 at the bottom. CSO, yes. So we do the same. Another thing in Altium is what you can use. I'm going to lock this. So I copy this. I choose its center point. Now when I paste it, I'll show you this trick. This is quite a, KiCad does not have this. So I copy this, I choose a center point, and then I use my favorite keys J and L. So Control V, J, L, so it's jump location, and then I can choose either delta or a new position. So I know my X is 0. I'm lying again. My X is 3 plus 2, 5, and that's 0. And then it'll be 2 millimeters apart because this was 3 and that one's 5. Now I can just go back and copy with reference. Guys, please let me know if I'm going too fast. I'm just winging it on the fly. 1, 2, 3, 4, 5, 6. Yes. Designators are important. So that's 14. So 15 to 22. Now we do the same here. I can use this. You see it's not snapping because it's set on snap only current layer. My current layer is red. So I'm going to go all layers. Copy. And I can do the same here. Boom. I can do the same here. I wonder if I can go take that, highlight that, and then copy, save some time, and then I paste it. Nice. How nice is that? Hey, is you still with me? I haven't lost you yet. I'll send you this footprint and you can use it in your project if you want. If you want to make it yourself, you can as well. We'll add this to our library in GitHub as well. HUD, what's HUD? There we go. Now we can make it pretty. Just make sure everything's locked. See if everything lines up. It's fine. But now we just have to I'm lazy, man. I'm lazy. So let's just make some nice silk place line. Your silk can't go over your pads, guys. Or you can, they just won't produce it. So it's all up to you. This is just how you want to make it pretty. This will be how it looks on the board. So you can see I should have some white line now. So I'll hide this. You can see the white line there. So another thing we're missing is it's not that important on this board or this board, this footprint, because there's only one way you can make it. But get in a habit to always put like a dot. How to make a dot? Just so you can indicate pin 1. So I can make this one. So just for future reference, you know that's pin 1. So for this IC, it does not matter because you can't turn it the other way around. But for other ICs, just going to have it pin 1. And we're also missing place. We saw this is 3. Actually, I don't think you have to put that. I think that comes automatically. I'll have to have a look. So now it's starting to look like something. And we can be creative. You can actually just do whatever you like. So you won't see it, but once you hide it, change the background. So we save this. So what I normally do is, you can see my libraries are here. And then I normally put it in my project. So I take it in my project. Oh, it's not working. So when you get to your schematic we just made, you can go at the bottom here and footprint, add, footprint, and then you can choose a library. So browse, this is the library we just made, and I'll connect those two. And now this will be linked. The two will be linked. So if I go to this, place component, I've got my plumbot library. There's my component. Pop it over, save. Let's see, tools, annotate. Design update. It should add it now, hopefully. Shush. Let's not put it here because I copied, in this project, I copied the thing 3 times. So if you can see it, I copied the sheet 3 times. So I'm just going to put it on top level just to show you guys. So this is a different project. Strange. So it doesn't seem to be linked properly. There it is. Yeah, because I made this 0. Now it should be there. I wonder if this helps here now. I probably have to, if you make a change on your schematic side, you always have to update it again. I think push update something for action. Yeah, you can see I can update it. There we go. So now if you go tools, update, design update, nothing. So does it automatically go? Let's see. Let's just do it manually. Not too sure why the 3D is not showing. Delete and just redo it. Because my 3D should be there now. Yeah. Yeah, there we go. That looks nice. JS, you happy about that? Are you happy with what we did? Do you want me to share this, send this footprint to you? I'll share on Discord. Anything else, Mr. JS? Is it Mr. or Mrs.? I don't know. I mustn't use words because I don't know. Yeah, so this was just a battery charger we made for 4 LiPo batteries. So you're welcome. Do you want me to share this or would you like to make it yourself? Guys, any other questions? I think probably going to go eat and stuff and then work on the drone. So the drone is going quite well. I think it should be done by the end of this week. And then I'm going to make short videos explaining it and then show you guys how to do it yourself. But it's going well. It's challenging. Great. I'll share the on GitHub. So I'll show you guys. Have you seen our GitHub yet? If you go to PCB Design in Discord, and top you got pin messages. Yeah. Kamikaze, I'll be back tomorrow and carry on with the pixel the clock. So I think that'll be our next project to make the clock work. So we've got the drone that I'm busy programming. I've ordered the macro keyboard. So once the PCB comes, we'll do that. I've set clock. So it's nice to do stuff while waiting for stuff. All our streams are always just raw on there. I don't edit it. If I edit it, I add an extra video for highlights. But I'd never edit the live stream. So at our JS, if you go to our, do you know how to get to our GitHub? It's if you go to Discord, on the top right, there's pin messages. You can see the Plumpot thing, or you can just go to Plumpot 55 GitHub, and there you'll see we've got our PCB designs. So all our PCB designs are also freely available, the drone, the battery charger. And yeah, I'm starting an Altium library. I'm going to do the same with KiCad. So there is footprints that I've made that I don't want you guys to remake if you want to use it in projects. So there's two stuff, our PCB designs. I'll do the same for KiCad and our things. No problem, Jace. I'm here to help. Hey, Ramesh, how are you doing? It's going to be fun, this one. It'd be nice to have it for at work, take it to work. Guys, any more questions? Anything I can help with PCB-wise? Yeah, you can ask about other stuff as well. I'm just not sure if I can help you. Why is this stuff missing? Like, there's nothing anywhere. Strange. Yeah, so tomorrow I'll be back again. Same vibe, just chilling, helping where I can, and then I'm going to start making this clock. Doesn't seem too difficult, but who knows? Interesting. In which sense? To program, yes. To put on a PCB and solder myself, no. With the BGA, it gets difficult. But yeah, I've done, for my postgrad, I did FPGA radiation. So we had a FPGA where we shot proton beams at it. And what happens is when you shoot radiation at FPGA, you get a bit flip called a single event upset. So like if you have a pacemaker or something, the radiation causes 1 to become 0, 0 to 1. So we try to see how we can make that not happen anymore. So things like dual model redundancy, triple model redundancies, things like that. So I programmed an FPGA ASIC 3E, a Pro ASIC 3E. So that was pretty cool. But I've not touched it for about 5 years. So we're still at university. I would, if you want to, that's a good course to take because the FPGA is like a blank canvas, right? You can absolutely make anything with it. Parallel processing, all that stuff. I would definitely learn it. It's nice knowledge to have. And it's a scarce skill at the moment. We can't find a lot of FPGA programmers where I'm working now. What certification? So everything is certification. So if you want to sell in the EU, you need CE marks certification. America, you need UL. What do you mean by certification? There's different certifications, but there's a lot of certifications in the world. Is there a specific one you're looking for? What type of stuff you're making? What useless box? Like just a plastic box. I don't know. I'm not a mechanical engineer. I'm sure there's some sort of, I don't know, there'll be useless box lying around. Everything in life is a certification these days. A useless box. I'm looking for something useless. Don't know what useless box. Electronic useless box, or what do you mean? It's all about in which country you want to get it to and where you have to sell it. So every country is different. It's difficult to say. Like America, EU, I'm sure India is different. So Africa is different. Useless box. That made me laugh. Where does this answer go? How about a useless box? What are you trying to certify? Yeah, but what do you classify as a useless box? Like electronics, is it just a box that like those useless inventions where you open it and it closes itself? Or I'm not entirely sure what you mean by a useless box. I don't know you get useless boxes. Any box can be used for something. Let's see, Wesley tried to connect, but his device is not connected. Useless box. Bye, JS. Thanks for joining, man. I appreciate it. Yeah, if it's probably for kids, you're going to have to make sure it's not a choking hazard, I guess. Can they hurt themselves? I'm not too sure. I'm not an expert in that when it comes to safety. So that useless box, you mean like that one that you open and the finger comes out and closes again? I don't know. I'm sure there must be something. So if you've got a lithium battery in there, there's some different stuff you have to do. Certain labels you have to on packaging. There is some, but I can't. It's difficult for me to say. I don't want to give you advice and then it's totally wrong because, yeah. Is that something you are thinking about making? Where are you from, Ramesh? Maybe someone in the chat can help. I don't know. Maybe we should make use of this box. Cool. So I'm just trying to figure out what this NCO comes from. Guys, please feel free to share your nice projects on Discord. We've got a community channel chat where we all share our projects. So there are some people making some real cool stuff. And yeah, it's just a nice place to chat, share ideas, review projects. So 10 heads is better than none. Azerbaijan. I won't lie to you, I'm going to have to Google that. I'm sorry. Oh, wow. Close to Georgia, or next to Georgia. I know Georgia plays rugby, so I know Georgia. I learned a new place. Just shows how bad I am. That's nice. Well, welcome. Welcome. What's the time by you? It must be quite late. I'm reading about your country now. Baku, is that the capital? Why do you say it's slow? Because of appearance on the screen or on the chat? Because for you to appear on the screen, I have to click a button. So maybe I'm slow. I'm sure it's probably there. Cool, guys. Is there any questions, any other PCB related stuff I can help you with, show you? Otherwise, of course, you can join me tomorrow. No, nothing. I'll wait a while because it might be slow. But yes, so the drone, I will probably release a video tomorrow about part 2, about the PCB, the 3D housing. And that'll be our first community project that we are going to showcase, that we built together live like this. And then I'll share you already have the PCB design, so I'll share the code. So I'll share the code, share the step file for the 3D print. If it flies, if everything's perfect, I'll make it step by step so anyone can make it. You want leadership skills? Yeah, electronic questions, please. Don't know if I can help with that. I'm sure there's someone out there who can. Are you studying now, or are you working, or? What's your story, Ramesh? Maybe get some books, start reading. I don't know. I'm sure there's online training. Also depends what you classify as leadership, management. Yeah. Great, guys. So I think that's me. No more serious questions. So like I said, tomorrow we'll carry on like this, just chat about PCBs, electronics. Any questions? No, I'm in Ramesh. No, man, Ramesh. No, Nick, don't. No. Why you say that? Maybe for goodness, you wanted to do a board at home without going to PCB. So how would you set up KiCad to do a single-sided board? Okay, I can do that. We can go through it. You want to do it now, Lucky Tiger? So when you mean one at home, you mean etching? We can do it now, tomorrow. This should not be. You have time now, Lucky Tiger? I can show you. It won't be too bad. What type of project you want to do? Or is there a specific thing, or you just want to? Yeah, if you don't stop me, I'll just quickly show you. I need a circuit though. No, I'll show you. So all PCBs are kind of two layers. Let me just show you. Where are you from, Lucky Tiger? So let's take this for example. I've got two layer boards here, but I'm in Altium. Boom, wrong program. So this is actually a one-sided board. So on the top left here, you can go choose your board layers, but it'll always be two. You can switch it off here, can you? No. So the only thing you have to do is make sure that you only place components on the top layer. So you see I've got nothing at the bottom. So the manufacturer or you at home can just print this out. Just make sure everything's on one layer and then you should be fine. And then just make use of through-hole components. Just the trick. So sometimes if you do everything on the top layer, your tracks will not always be like this. It might be sometimes difficult to have space for everything on top. So what I would do is I would use 0 ohm resistors. Maybe some 1206s. So for example, I want I place a component here. Forward 6. So I put the resistor small. It's just a trick you have to do for single layers. This resistor has no purpose. The only purpose is so I can run tracks underneath it. So footprint, resistor store SMD. And I choose a nice big one like 1206. Tools, update. I need to annotate it first. So now I've got this. So if I ever have a track that I don't have space for, I can always run a track underneath it. So in that way, I actually jumped between these two lines, if that makes sense. That's a nice trick to do if you do stuff at home. Use resistors to split tracks and be able to run tracks through it. But if you do stuff on top, it will be one layer. You can't set Alt KiCad to one layer. Make sense? Sure, man. Cool. I'll see you guys tomorrow then. Probably about 11 in the morning my time. So, because I want to help Krish with these drone issues. But if there's any guys, any questions on Discord, just let me know. Any topics you want me to cover for tutorial videos on YouTube, let me know. I'm busy with the drone, as I said. I'll release the drone videos soon. Hopefully it flies or crash. Either way, I just want it in the air. Have a great night, guys. See you guys tomorrow. Bye.